right, let's look at 6.4 complex numbers and the quadratic equation. For quadratic equation, remember if we have f of x equals or y equals ax squared plus bx plus c, we can apply the quadratic formula to find the zeros. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, we actually worked that out to see completing the square gets us to this formula. Okay? If those zeros are real numbers, then they represent the x-intercepts or the root of the parabola. However, if this discriminant becomes a negative value, then we say there's no real solutions because those roots, there's still two roots, but they are complex numbers and the parabola does not intersect your x-axis. Okay, so let's look at some practice with this. If I want to find the roots of x squared minus 6x plus 12, generally what I would first start doing is I would go, okay, I would look at this 1 and this 12. 1 times 12 is 12. And then I'd say my multiples of 12 are 1 and 12, 2 and 6, 3 times 4, and then I need to get a negative 6. Well, the only way to get a negative value, if I have to get a positive 12, is both of these would have to be negative. None of those, if both of them are negative, are going to give me a negative 6. So that tells me that this is not factorable. If it's not factorable, then I have to go to my quadratic formula. Okay, so for my quadratic formula, I'm going to say x equals negative b. B is negative 6. Notice I had the negative and I still wrote negative 6, plus or minus the square root of b squared. I'm going to put my negative 6 in parentheses so I remember to also square that negative. Minus 4. 4 is just part of the formula, so that's always 4. A is 1. C is 12. All over 2 times A. A is 1. So x equals positive 6 plus or minus the square root of 36 minus 4 times 1 is 4. 4 times 12 is 48 over 2. So then I have 6 plus or minus the square root of 36 minus 48 is a negative 12 over 2. So I know this is going to be complex. I'm going to have an I because I have that negative 12. I'm going to come off to the side and just do some scratch work to simplify the square root of negative 12. So if I take the square root of negative 12, I know that negative is going to come out as that negative 1 part is going to be an I. But then I'm going to look at the 12 and say, are there any perfect squares that I could take the square root of that divide into 12, right? So all of these numbers divide into 12. If any of them are perfect squares, I want to take that one out. So see this 4? If I think of this as 4 times 3, then when I simplify this square root, the negative 1 is going to come out as an I. The 4 is going to come out as a 2, right? The square root of 4 is 2. And then 3, I can't do anything with that, has to just stay inside the square root. Okay, so I times 2 times the square root of 3 is what this reduces to. So this is really 6 plus or minus I 2 square roots of 3 over 2. Okay, now generally when we write this, we are going to want to write it in the correct format, and when we write a complex number, remember we write a number, and they used an x, but since I've got x's and y's over here, I'm not going to use x and y. I'm going to use m plus something times I, right? So I want it to look like this. I want to have a number plus or minus a number and then an I on the end. Okay, so I'm going to split this into the two fractions that it is. So this, when I split it, I'm going to have 6 over 2, well that's just 3, plus or minus, and then this I is going to go on the end. So I'm just going to think about 2 square roots of 3 over 2, and then that I is going to go to the end. But this is simplifiable, right? That cancels out. So my final answer is going to be 3 plus or minus the square root of 3 times I. Okay, and so one solution is 3 plus the square root of 3i, and the other one is 3 minus the square root of 3i. Which again, we can't graph on a traditional graph because of the imaginary number. Okay, let's look at the second one. So again, if I were going to try to factor this one, I would take my 4 times my 2, which is 8. My multiples of 8 are 1 times 8 and 2 times 4. If I want to get a negative in there, then both of these would have to be negative so that I'd get a positive 8, or both of these would have to be negative so I'd get a positive 8. Neither of those make a negative 3, so again, this one is not factorable. So I'm going to have to resort back to my quadratic formula. So x is going to equal negative b is negative 3, plus or minus the square root of b, negative 3, squared minus 4 times a is 4, times c is 2, all over 2a. All right, let's start simplifying this. So negative 3 is positive 3, plus or minus the square root of negative 3 squared is positive 9, and then I only have one minus sign, so minus 4 times 4 is 16, and 16 times 2 is 32. Oh, I did 2 times a there, but I know what a is. A is 4. So this is all going to be over 8. So this is going to be 3 plus or minus the square root of negative 23 over 8. Now if I were to come off to the side and think about the square root of negative 23, oh, excuse me, 23 is a prime number. Nothing divides into 23. So I can only split this into negative 1 times 23. And then I know that negative 1 is going to come out as an I, and I'm going to be left with my 23 inside. Okay, so going on, I'm going to have 3 plus or minus I square roots of 23, that's an I, over 8. And then again, I want to write it so I have a number plus or minus a coefficient on I. Okay, so when I do that, I'm going to have 3 over 8 plus or minus, and then I'm going to have the square root of 23 over 8 I. This does not reduce, this does not reduce, so this is my final answer. Okay, now that's great if we have our equation. If we don't have our equation, and we have to find our equation first because we just have a graph, let's see if we can do that. Okay, so we have had problems in the last unit where they gave us a graph and they said, hey, what is the standard form of, or what is the standard equation or the general equation of this parabola? Okay, in order to do that, you have to have two things on your parabola. You have to have the vertex, and you have to have a point, another point. Okay, remember your vertex is always given to you as an HK. So my vertex is going to be the point 1, 2, 3, 4, 2. So my vertex is the point 4, 2. So I know my value for H is 4 and my value for K is 2. And then my point is just another coordinate. So it's just an XY coordinate. The point that I have is the point 2, 1, 2, 3, 4. It just happens that they're reverses of each other. That doesn't always happen. That just happens to be the way that this one works. Okay, so then what I'm going to do is I'm going to use my, since I have a vertex and I have a point, I'm going to use my vertex form of the quadratic equation. The vertex form is y equals a times ax minus h parentheses squared plus k. And then I'm going to substitute in the h, the k, the x, and the y so that I can find this a value. So y is 4 equals a, I have no idea. X is 2 minus h is 4, close parentheses squared, plus k is 2. Okay, and now I'm going to solve this for a. So 4 equals a times negative 2 squared plus 2. So 4 equals, negative 2 squared is 4, so that's going to become 4a plus 2. Okay, then I'm going to subtract the 2 on both sides, trying to solve for a. That is going to give me 2 equals 4a, divide by 4. And that is going to give me 1/2 equals a. So now that I know what a is, and I know my vertex, I'm going to use those to write the equation in vertex form with all the numbers that I need. So y equals a, 1/2, times x minus h is 4, close parentheses squared, plus k is 2. I'm going to multiply this out and simplify this so that it's in general form so I can apply the quadratic formula. Okay, here's how I do that. X minus 4 squared, so we can multiply x minus 4 times x minus 4 and we can double distribute and then combine like terms. Or if we remember that when you square a binomial with a minus sign, then a pattern happens. The first term gets squared, and then it is minus these two terms multiplied together and then doubled. So 4 times x and then doubled, that's 8x, plus the second term squared. So negative 4 squared is 16. Okay, plus 2. So I just squared this. Again, if you don't remember that rule, it is on one of the posters that I have over on the wall, but you can always do x minus 4 times x minus 4 and double distribute. And then combine these like terms to get that negative 8, that 16, and that x squared. Okay. The next thing I have to do is I have to distribute this 1/2 so that it multiplies to this whole thing here. Okay, so I'm going to have y equals 1/2 x squared minus 8 or minus 4x plus 8. So just divide each of these, multiply each of these by half. And then I still have this plus 2 sticking on the end. That's outside the parentheses, so it doesn't get the 1/2 treatment. I'm just going to combine these like terms on the end, the 8 plus the 2. Y equals 1/2 x squared minus 4x plus 10. Okay? All right, so the next thing I'm going to do is I'm going to apply my quadratic formula. Okay? So all of that was just to get here, and now I'm going to take this and apply the quadratic formula. So x equals negative b, negative 4, plus or minus the square root of b minus 4a c all over 2a. 2a. So that is going to be 4, positive 4, because minus 4, plus or minus negative 4 squared is a positive 16. Negative 4 times a half is a negative 2, and negative 2 times 10 is a negative 20. Over 2 times a half, or half of 2, is just 1. So I don't really even have to write it over that 1. So 4 plus or minus the square root of 16 minus 20 is negative 4. I don't have to put it over 1 because, it's not a fraction anymore. Okay, so now I just need to think about simplifying the square root of negative 4. That's the square root of negative 1 times 4. That's going to come out as an I. That's going to come out as a 4. So this is going to turn into 4 plus or minus. I'm just going to switch the order of that so that way we're in our number plus or minus a number times I. Oops, that's not going to come out as a 4, right? This is going to, I didn't take the actual square root. When I square root that 4, when I square root the negative 1, I get I. When I square root the 4, I get 2. So that should be a 2 right there. So those are my two solutions, 4 plus 2i and 4 minus 2i. Let's do one more like that, okay? All right, so same situation I've got going on here. The first thing I want to do is I want to say, okay, I've got a vertex. That's my HK. My vertex is at negative 3, negative 1. And I've got a point. That's my XY. My point is at 1, 2, 3, negative 4. 1, 2, 3, negative 3. Okay, so I'm going to put that into my formula. Y mine equals A times X minus H, close parentheses squared, plus K. Except we're going to replace everything, right? So Y is equal to negative 3 equals A times X. X is negative 4 minus H. H is a negative 3. So if I do minus the negative, undo that. Minus the negative 3, it's just going to turn into a positive there. Squared. Plus K, and K is a negative 1, so instead of doing plus a minus 1, I'm just going to do minus 1. And then I'm going to simplify. Negative 3 equals A times negative 4 plus 3 is negative 1 squared minus 1. I'm going to square that negative 1. A times negative 1 squared is just 1, so that's just A times 1, which is A minus 1. Addition property of equality, move that 1 to the other side. Negative 2 equals A. So now I'm going to go back to that first equation, y equals x minus h, close parentheses squared, plus k, and I'm going to, oops, I forgot my a, squeeze that a in there, and I'm going to fill in everything that I know now. So y equals, now we know a is negative 2, times x minus h. H is negative 3, so that's going to turn into a plus 3. Close parentheses squared, and then plus k, but k is a negative 1, so I'm going to put minus 1. So this is my equation, but I want to convert it to the standard or general form so that I can apply the quadratic formula to it. So to do that, I am going to say y equals negative 2. And then I'm going to multiply this out. Again, if you need to come up to this side and do x minus 3 times x minus 3 and double distribute, and then combine those like terms, you can. Or you can use the rule that we learned that says you take your first term and square it. You multiply your two terms together, 3 times x, and double it, so that's 6x. And then you square the second term, and then they have that minus 1. Okay, then the next thing I need to do is I need to distribute this negative 2 to the 3 things inside those parentheses. Everything except the k on the outside. When I do that, y equals negative 2x squared minus 12x minus 18. And then I still have this minus 1, so all I have left to do is combine these like terms on the end. Y equals negative 2x squared minus 12x minus 19. And this is what we're going to put in our quadratic formula. So in my quadratic formula, x is going to equal negative b plus or minus the square root of b squared minus 4ac. A is negative 2, c is negative 19, all over 2a. A is negative 2. All right, so x equals negative 12 is a positive 12, plus or minus the square root of 144, positive, because when I square a negative, it becomes positive. And then 4 times 2 times 19, negative, 3 negatives means it's going to stay negative. 2 of them will turn positive, but I'll have 1 left. 4 times 2 is 8, and 19 times 8 is 72, and that is going to be 152. Over 2 times negative 2 is a negative 4. So then x equals 12 plus or minus the square root of 144 minus 152. I'm going to take away the 144 here. That's just easier for my brain to do. That's going to be 8, but I know the bigger number is negative, so it's going to be a negative 8 over negative 4. Okay, I'm going to simplify the square root of negative 8. So the square root of negative 8 is going to be the square root of negative 1 times 4 goes in there, 4 times 2. So that's negative 8. The square root of negative 1 is I. The square root of 4 is 2. And then this 2 is left inside. I can't square root the 2. So this ends up being 12 plus or minus the square root, I, 2 square roots of 2 over negative 4. And then we want to divide these separately by that negative 4, and we want to put that I on the very end. So 12 over negative 4, that's negative 3, plus or minus the 2 square roots of 2 over 4. So the 2 over 4 is 1/2. So that's going to become just the square root of 2 over 2. And then don't forget that I on the end. Okay? All right, the last thing we're going to do in the notes for today is we're going to look at what happens if we know the 2 roots. Can we use, and we know an a value, can we use those 2 roots and the a value to find the quadratic function in standard form? Okay, I'm going to jump ahead to where your homework is and talk about one of your, or not your homework, your exercise, and talk about one of the things they're going to ask you about in your exercise. They're going to talk about, instead of thinking of this as 2 plus 5i and 2 minus 5i, if I think of this as m plus or minus ni, where m is 2 and n is 5, right? Those are my 2 roots. That is going, we get this answer by doing the quadratic formula, right? By doing negative b plus or minus the square root of b squared. Let me make that a b. B squared minus 4ac, all of this over 2a. And then when we solve this, right, every single time we solved this, we did like 4 of them, I said, okay, now let's separate this into the real number and the imaginary number, right? So then we said, okay, the way we got our m plus or minus our ni is because we took this, and once we solved it, we separated these into b over 2a plus or minus the square root of b, whatever this simplified to, b squared minus 4ac. And this side was over the 2a. We just divided this into two separate fractions, right? This fraction and this fraction. Okay? Well, then this number became our n, our m, right? So m is going to be whatever negative b over 2a is. And ni is going to be whatever this equals. So ni is found using the square root of b squared minus 4ac all over 2a. All right, so now knowing that, and this is basically what they're going to be asking you about on your second, I believe, question in your exercise for today's exercise. Okay, so refer back to this. All right, so now if I'm looking here, my m plus ni, or plus or minus ni, what they've given me is 2 plus or minus 5i, right? So I can see that my m is 2, so m equals 2, and the ni equals the 5i. So ni equals 5i. And they also, one other thing that they told me is they told me that a is equal to 1. Okay, so this is going to be important in finding our a, b, and c values so that we can write our goal here. In case I didn't specify that, we're trying to write the standard equation. Okay, the ax squared plus bx plus c is what I'm trying to do. I already know the a, so I know it's going to start x squared, but I don't know the b and the c. Okay, but now I know that m is equal to negative b over 2a. I know what a is. A is 1, right? And I know what m is. M is 2. So m is 2. That equals negative b over 2 times a. A is 1. So now we just simplify that. M equals negative b over 2 times 1 is 2. Right? Oops, I shouldn't say m. We know what m is. M is 2. Then, to get this 2 out of the denominator, I'm going to multiply both sides by 2. So on this side, these cancel out. I'm going to have 4 equals negative b. Divide both sides by negative 1 to get rid of that negative on the b. And negative 4 equals b. So now I know what b equals. I know what a equals. All we have left is to find what c equals. So the next thing I'm going to do is I'm going to look at ni. Ni equals the square root of b squared minus 4ac all over 2a. I know what ni equals. Ni equals 5i. That equals the square root of b squared. I know what b is. B is negative 4. Minus 4a. I know what a is. A is 1. C. I don't know what c is. All over 2a. I know what a is. A is 1. Now let's simplify this and solve for c. So 5i equals the square root of 16 minus 4c all over 2. I'm going to get rid of that fraction by multiplying both sides of my equation by 2. so that that will cancel. And I'll have 10I equals the square root of 16 minus 4c. How do I unsquare root? I square. So I'm going to square both sides. When I square both sides, let me scroll down just a hair. When I square both sides, that's going to become 100I squared equals the square and the square root here are going to cancel. This side's just going to be 16 minus 4c. Now, I need to remember that I squared is really negative 1. So this is 100 times negative 1. This is negative 100 equals 16 minus 4c. Subtract 16 on both sides. Negative 116 equals negative 4c. Divide both sides by negative 4. And that's going to give me negative 116 divided by negative 4. 100, that's 25, 60, 29. Positive, because negative over negative, 29 equals C. So now I know A is 1, B is negative 4, C is 29. I can write my equation. My equation is y equals x squared, 1x squared, that's my A, B minus 4x, C plus 29. This equation will have the roots plus or minus 2 plus or minus 5i. Okay? All right, using that information, you now have enough information to do exercise 6.4.1. Once you're done with that, you have learned everything for this unit and you are ready to go on to the Unit 6 college homework. And then once you're done with that tomorrow, the quiz for Unit 6 will open up. All right, thank you so much for watching.